Welcome students, this is Ravi Shankar. So let us go with the exercise problems. Already we have studied about 7 example problems, and in this video let us go with two exercise problems. The first problem, you just go through the problem. When two objects are rubbed with each other, then approximately a charge of 50 nanocoulomb can be produced in each object. Calculate the number of electrons that must be transferred to produce this charge. Go through the problem again. When two objects are rubbed with each other, approximately a charge of 50 nanocoulomb can be produced in each object. So the charge available is considered to be Q. So when you are considering the two objects, one of the object is having a charge Q1, the other object is also having the charge Q2. So in general I am considering the charge available as Q, which is equal to 50 nanocoulomb. In standard value, we have to write it out as 50 into 10 to the power of minus 9 coulomb. Now, what it is asked, the number of electrons that must be transferred. The number of electrons available is n. We have studied about the quantization of electrical charges. Use that formula. So, according to quantization, properties of electrical charges. In properties of electrical charges, we have studied about this. According to quantization of electrical charges or electric charge, according to quantization of electric charge, the total charge available Q is equal to N into E. Therefore, the number of electrons available N is equal to Q by E. What is Q? 50 into 10 to the power of minus 9 divided by, what is the charge of one electron? 1.6 into 10 to the power of minus 19. So simplify and get the answer. It is your task to simplify and get the answer, and you should get the answer as 31.25 into 10 to the power of 10 electrons. Or you can say it out as 3.125 into 10 to the power of 11 electrons. So simplification you have to do. Taking the logarithm for these two, you have to simplify. If you want, I can put only one question, logarithms for one. The remaining you have to do. Okay, when you are considering numerator, you take 50. For 50 it is 50, isn't it? 1.6990, and it is for 9 bar, you can say 9 bar 0.0000. You add it out and that is the value of numerator. Similarly, you get the values for denominator. What is the value for 1.6? 1.6 is 0.2041. And again 19 bar, you will be getting 19 bar 0.0000. Get the denominator value. After this, you subtract numerator minus denominator. Subtracting numerator minus denominator, you will be getting a value. For that value, you take anti-logarithm and get this answer. Clear? Okay, you have to do, because if you want to make the problems thorough and if you want to get hands-on practice, you have to solve the problems. The method we can dictate or we can guide you. Okay, try to get the answer. If not, let us see when we are meeting it in person. Okay, now you see, when you are considering about the second problem, say a long problem, a lengthy problem, the total number of electrons in a human body. They are considering a human body, and in that human body, the number of electrons available is considered to be in the order of 10 power 28. So in a human body, there are 10 power 28 electrons are available. Suppose due to some reason, you and your friend lost 1% of this electrons. See, in this total numbers, if 1% is lost, remaining will be the charge. So 1% of this electron is lost. You are asked to calculate the electrostatic force between you and your friend. If they are, or if you are separated by a distance of 1 meter, then compare this with your weight. Assume the mass of each person as 60 kg, each person as 60 kg, and you consider as point charges or point mass. That is what it is given as. Use point charge approximation. Come on, go through the question again. The total number of electrons in a human body is taken to be 10 power 28. Okay, then suppose due to some reason you and your friend lost 1% of this electrons. What will happen? The human body will get charged on losing electrons. The charge is positive. Calculate the electrostatic force between you and your friend separated by a distance of 1 meter. Then compare this with your weight, assuming the mass of each person as 60 kg, and take the charges as point charges. Okay, let us write the data given. So in solution, let us write the given data. What are the given data? First of all, the number of electrons available originally. Number of electrons originally available. Originally available in a human body. How much? It is given as 10 power 28 electrons. The next one, the percentage of electrons lost. So let us write like this: percentage of electrons lost. How much percentage lost? 1%. Then you can say like this: 1 divided by 100. If 1% is lost, what is the charge acquired? So I can write charge acquired by the human body is equal to, see, in this total number of electrons, lost is 1 divided by 100. So the charge available is 10 to the power of 26 coulomb. What else they have given? The distance of separation R is equal to 1 meter, and charge acquired by you and by your friend. So I can write Q1 is equal to 10 power 26 coulomb, and Q2 is also equal to 10 power 26 coulomb, and or I have written it as 1 meter, and I have to calculate what? And I have to calculate what is the force between, or electrostatic force between you and your friend. So let us write the formula first of all. The electrostatic force is given by the formula F of E equal to 1 divided by 4 pi epsilon 0 into Q1 into Q2 divided by R square. You know this values, isn't it? Substitute. What is this? 1 by 4 pi epsilon 0. It is 9 into 10 to the power of 9 into, what is Q1? 10 power 26. What is Q2? Again 10 to the power of 26. Whole divided by R square. R square is 1 square. So on simplifying, you see 26 plus 26, 52 plus 9, you will be getting it as 61. So 9 into 10 to the power of 61 Newton. That is the electrostatic force. So electrostatic force F equal to 9 into 10 to the power of 61 Newton. This is the electrostatic force between you and your friend. Okay. What is the next one asked? Next one asked this. You are asked to compare this force with the weight. Isn't it? What is that weight? weight is nothing but mass into gravity. So we have to calculate what is the weight of the human body. What is the weight of the human body? The weight of the human body is equal to W. Let us consider that weight as M into G. How you can get the answer? W equal to M. It was given as 60 kilogram. G, you can consider it as 9.8. For approximate, in case of approximation, you can 10. You can take 10. See, given what? Given M is equal to 60 kilogram and acceleration due to gravity G is 9.8 meter per second square. So on multiplication, nearly 600. So on multiplying, we will be getting the answer as 588 Newton. This is the weight of the human body. You can very well compare. The electrostatic force is considered to be very higher than that of the weight of the human body. Okay, we have gone with 2 problems from exercise. You try to solve it with the help of logarithms and try to get the answer. Okay, let us see in the next video. Thanking you.